Thank you for coming. My name is Eoin Woods, which for those of you who don't know me, that's not obvious. If you leave the E off the front and pronounce the rest of the letters, that's the way to remember it. I'm a lead software architect for a large European bank called UBS, where I'm the head architect for the securities processing bit, which if you know what back office securities processing is, you know exactly what I do. And if you don't work in banking, the details aren't really important, except we do a lot of very large systems that process millions of transactions a day, typically not time critical, but very volume critical. That's the kind of systems we work on. I'm going to give a talk today, quite an opinionated talk about UML. Those of you who know me will not be disappointed. And as you might guess from the title, if you've come for a detailed analysis of all of the nuances of UML2, you're unfortunately in the wrong session. What instead I'm going to do is explain why I think UML2 has some benefits, and it's actually very useful, provided it's used in the right way. It's a little bit, I think, like most complicated technologies that have lived for a long time. If you talk to an expert C++ developer and ask them to go into the corners of the standard, they'll just kind of raise their eyebrows and explain why nobody uses that stuff. And I think there's quite a lot of that in the UML2 language. So I'm going to give quite an opinionated talk, which I'm sure people like Bram Selleck, who's a great UML2 advocate, would find absolutely horrifying if he sees it afterwards, which he might, of course. I might be getting an angry email in the Tom Gilb style. He probably wouldn't like this, because I sort of abuse UML2, but I think I am basically a friend of it, just a rather critical friend. So that's the kind of talk it will be. I'm going to talk to begin with about modeling, because actually the point isn't UML. The point is modeling and why we bother modeling. UML2 is a vehicle for describing models. And if you don't want to do modeling of your systems, there's no point learning UML or any other modeling notation. So I'll talk a little bit about modeling. And then, having actually covered the important stuff, I'll then spend 90% of the talk talking about UML, because that's what's in the title. Just briefly explain where UML came from. I don't know. I think people with grey hair probably know where it came from. People who are still young and enthusiastic perhaps don't. So I'll just explain how it got to where it is. That is pretty quick. And then I'll describe a whistle-stop tour. I will go through all the diagrams, but in order to keep you awake, I'll do it quite quickly. And I'll try and make it as entertaining as possible. Can you imagine that? Entertaining whistle-stop tour of UML. This could be the first. Then most of the talk is using the good bits. There are a set of diagrams and models that I have found that I have been using repeatedly. Some of them are part of the UML standard, and some of them aren't. Some of them happen to use UML as a notation. I'll explain how I go about describing a system. I'm not going to do a full case study. I don't think it's really required, and there's a number of them out there. And frankly, if it was a day's course, we could do a case study in great depth. But I'll show you lots of fragments, which are completely artificial. I completely accept, because I've created them for this course. But it means I can put them on a slide. I'll then have a shorter bit about bad bits. It's kind of implicit. Stuff I'm not talking about, clearly, I don't think is as important. But there are some bits of UML I think are positively bordering on the harmful, and I will talk about those briefly. I'll then talk a bit about making UML your own. I realise that slide's not been updated. That's actually much earlier. The point about UML actually is that it's a good base for building your own modelling language. I'll explain how to do that briefly. And then you'll notice I don't talk about tools until the last 5 minutes. In fact, I've relegated it to 2 slides, I think, at the end, because tools are almost irrelevant. You actually do need a good one, but the kind of tool safari people go on as the first step in adopting UML is missing the point so widely. They're clearly talking about something else. So, on with the content. Modeling then. What is a model? Well, actually there's lots of definitions of model. I thought it'd be really easy, so I went to Wikipedia, and then I thought, oh, life's too short. Model seems to be a rather philosophical concept, and many people in many fields have got many, many views of what a model is. I am taking, in fact, despite the crack about him, I actually think Tom Gilb talks a lot of sense. And I'm kind of broadly in his school of, this is a branch of engineering, and I'm talking about an engineering model. And a model is a simplified representation of reality. That's all it is. It's reality with some stuff taken out, really. And it can be spreadsheets of data. A Java domain model is a perfectly valid model of your domain. In fact, it's a very valuable one. And a UML model is a perfectly valid model of something. Who knows what it is? Maybe your domain. Hopefully your domain. The point is, modeling is about identifying a group of concepts which are important to you in your specific environment. And this is where I think a lot of structured methods and UML and software engineering methodology, to use that horrific American word, have gone badly wrong. People create lots of artifacts containing concepts they don't quite understand, and they certainly don't think are very important to them. And modelling is the process of finding the concepts that are really important to you so that you can understand them better, or you can communicate them. And I'll talk about how you use models in a minute. So the point is, a model's not just a picture. Equally, a model isn't just code, as Eric Evans seems to insist, that if it's not running code, it's not a model. I mean, he's taking a position there clearly to make a point, and he's sort of right. People don't think of their domain models as models, and that's wrong too. But all these things are perfectly valid models. One of the models I use probably a lot more than I used to, and quite a lot today, is a spreadsheet of data. Not financial data, but data about my systems, to do with sizes of code, or speed, or distance, or latencies, and I stick it all in spreadsheets, and I build simple numerical models to help me infer things about what is likely to go on in my systems in the future. So why bother creating models? 3 main perspectives. Again, you'll get a lot of perspectives on this. Just type modeling why into Wikipedia or into Google. There's 3 reasons I think we create models as software engineers. We need to communicate ideas to other people. If you need to explain to someone how something's going to work, what's the first thing you tend to do? You tend to pick up a pen, don't you? And you tend to start drawing boxes and lines. What you're doing is creating some kind of a model in someone's head, so it's communication. And clearly, different kinds of people need different kinds of models. You use it to form a record of something. How many people have adopted a 1 million line of code source base? Some of you. 500,000? Oh, you've all led charmed lives. Give it another few years. Allow a few mergers and acquisitions to happen. Then you'll be in the world of pain the rest of us have had. Not having a record of the concepts and abstractions that the people who built the code thought they were building, never mind if they got it right, but even the ones they thought they were building, makes 1 million lines of code very, very difficult to understand. And I've been in this slightly unenviable position now on a number of occasions. Maybe I've just been the unlucky one, I don't know. You all build new stuff all the time. But if you haven't got a record of the moving parts, I mean, to use an analogy which I think is much more relevant than buildings, aircraft, for example, because a nephew of mine is an aeronautical engineer. I know you wouldn't think I was old enough, would you? But he talks a lot about how management of the models for Boeing aircraft or Airbus aircraft, he actually works for a third-party company, is a major challenge for them, because we think our systems are complicated. And actually they are, but compared to a Boeing aircraft, actually they're pretty accessible. You can explain it in the morning. You know, Boeing are still chatting on Friday evening, and they still have only covered the major concepts in the aircraft. Yeah. So a lot of disciplines have this problem. How do you maintain the conceptual structure over time so that people understand how all these nuts and bolts in the aircraft case, or lines of code in our case, actually form something bigger than the sum of the parts? And finally, understanding, and this is one of the things that I use models for personally a lot, especially my spreadsheets. How do you understand how something's going to work, and how do you analyze the impact of change or the impact of proposed extension if you don't have a good representation of the thing? I mean, one of the things that I keep tripping across is, because I've moved into a new area quite recently. I've only moved into the operations IT group in the last year. And so I'll look at a proposed change and I'll think, to me that looks quite complicated and difficult, but I'll go and talk to some experts. I talk to people who know all about the system, and they assure me that because of the following facts, it won't be too bad after all. And what do you know? It is. One of the reasons is because I don't have a model of quite a lot of our systems yet. And so people often know parts of it, and so the record is a bit weak, but gaining an understanding without a full model of how the thing works is really very difficult. Then just to talk briefly about models versus pictures. So I accept boxes and lines on a flip chart are a visual representation, are a kind of visual model. But in UML terms, and I would say in useful, valuable modeling terms, if you're going to invest a lot of money in a model has to contain the definitions. It actually has to say what the boxes mean, and it has to have some kind of representation of the boxes, ideally in machine processable form. And I'm trying to motivate you now about UML. This is one of the things UML gives you. UML has a data model underpinning all of those pictures. You could actually take a UML model held in, there's a standard format I won't bore you with, it's called XMI. You could render that UML model in any way you wanted. There's absolutely no need to create standard UML diagrams. In fact, I have rendered UML models in web pages, I've rendered them to Excel, I've rendered them to Glyphy-style informal diagrams, just to give people summary views. The model is the important thing because it's the actual data, and these pictures we draw are views of the data. And that's what separates a full model from a bundle of pictures. And having separate pictures without any model is where the whole Visio approach goes wrong. What happens when you've got a lot of Visio pictures of some similar concept? What happens within 3 months?
Disjoint.
Exactly. Disjoint, out of sync, change here, didn't get changed here. And I see this a lot in enterprise architecture, which is an area I sort of overlap with, where they draw a lot of landscape diagrams, and they probably are accurate, well, maybe, on the day they drew them. And I can be reasonably certain within 6 months that because somebody's subset it apart and taken it off to talk to his stakeholders about and made changes on it, those changes didn't ripple back. If he was changing a model, there'd be nothing to change on the other diagram. The other diagram would just change. Lines would disappear, things would get renamed. And if you use a UML tool, and I'll briefly talk about tools, this is what they give you as opposed to Visio. They give you a database which has a number of visual representations. So when I change one bit, one model, in fact I could demo this if we get time, you change one model, one bit of the model through the picture, the other bit changes automatically. And that's actually pretty important for keeping coherence. There's also then how you go about modelling, because Martin Fowler wrote some very interesting stuff about this quite a long time ago. As you know, a long time ago he was something of an advocate of UML, and I think he's probably flipped entirely the direction now. But he did write definitely one of the very widely bought books on UML, UML Distilled, which is still in print. And he talked about this, and Simon Brown has talked about this a lot, I think in the last couple of years. And the way that I think about the types of model, and to be clear, all four are valid and valuable, you just need to decide which one you're doing. And the problem I see is people don't know which one they're doing, so therefore they get very mixed results. You can have a lot of detail in a model, or you can have not much detail in a model, and you can make it very precise, or you can make it rather imprecise, rather woolly. And deliberately, that's fine. If you're dealing with a senior business manager, he doesn't want a lot of precision. He wants to know that you've got trades and a system, and they get processed and they get reported. As far as he's concerned, this is job done. Where do I sign the check? Now, clearly, when you then go and talk to the head of regulation and control, he's somewhat less enthusiastic about the definition of reported, and he'd like to know exactly what you jokers are going to do that's going to be different this time to the last 3 fiascos. So in the low precision, high detail area, this arguably is probably the least valuable of them. But this is where you're not quite sure if all the detail. You're not quite sure if all the detail is correct, but you're going to try and get into detail to try and drive out questions. So this is when you start sketching on the whiteboard and you start with just blocks, but actually you start writing in method names or you start writing in lots and lots of detail. You know, that's probably not going to be tremendously valuable long term, but as an exercise to get people to think, this can be very useful. I would suggest that's not a long-lived model. High detail and high precision, I've later on I actually use that very diagram as an anti-pattern of UML. I don't believe representing code in UML is in any way valuable, and I think MDA was a horrific wrong turn for the entire OMG and the language, and I think it's one of the reasons it died, was that, well, it didn't die exactly, but the specification advancement process largely came to a halt because it had got complicated enough that people like you and me didn't care anymore. We didn't want to add more stuff to it because it was too hard already. And it was being driven by this, wanting to represent code in UML, which I think is entirely wrong-headed. So in fact, although I say they're valid, this bit I think is only valid in certain circumstances. Very unfortunately, the academic community loves this. I do quite a lot of co-work with academics. I've got quite a lot of published work in the research field. And I keep coming across academics who want to collaborate with me to produce more of this. Which I keep asking questions like, who is supplying your funding? Let me call them, and I will rectify that. Because this is, I think, is an utter waste of time. Low detail, low precision. This is your classic whiteboard sketch. Extraordinarily valuable for getting a few ideas over quickly and driving people towards thinking more precisely. And then relatively low detail but high precision, this is how I use UML. By low detail, I mean an abstract model. I'm not trying to represent the code. I'm only trying to represent the stuff I can't get from the code. But I am trying to be rather precise about it. These are real POJO services. This is a real dependency relationship. It really exists. I can go to code and find some representation of it. Once you've got a model, and I'm assuming now you've actually put a model into a database, so you've actually got data, what could you use it for? You can use it to check consistency and ensure consistency, because if you change something on one diagram, it will be represented in the other, and that for me is a huge, huge win. You can use it for reporting. Remember I said you can render this model many different ways. I have had quite a lot of success actually dealing with business people on architecture maps. You know, you've got applications and flows between them, generating spreadsheets out of the UML model, using a plugin to a tool, giving the spreadsheet to business users, and they'll happily go through the spreadsheet. But for some reason, I give them the big picture, and they go, yeah, it's fine, and hand it back. Whereas you give them a spreadsheet, they'll go, oh, that's not correct. Oh, you don't understand. And they'll actually annotate the spreadsheet, and then you can put that back into the model. So you can report things, and you can ask questions. If I change this, what's going to be affected? And actually, UML tools today can do quite a lot of that for you. Checking and validation. You may or may not find this important, but you can ask questions such as, if I've defined deployment components, things that should go into production, is there somewhere they go into production? I don't actually think those kind of questions are necessarily best done in UML, but you can definitely ask those kind of questions. And maybe most important, sharing information. Once you've got a model, you can generate many different views of it and really communicate with different people in different ways. There's no reason you can't render onto PowerPoint. You render onto PowerPoint. PowerPoint isn't the model. It's just a view of it. And wikis being another great one. So, let's introduce UML. Where did it come from? It's quite old. I don't know if that shows it or not. It's very, very sophisticated, but it certainly has the ring of something that's been around a long time when you look at how sophisticated parts of it are. It started back in, and I can remember this, I know some of you can't, there were 3 methods. That was called Rumbao, Booch, and OMT, which was, I've forgotten his name now, the third Amigos method, which came out of Hewlett-Packard, I think. They merged for purely commercial reasons. Fascinating people to talk to, people who are rational back in the early days about how they came together and the real motivations and the kind of deals done over beers as to why we're going to cooperate. These 3 guys realized very shrewdly there was a tremendous amount of business value they could get from merging their methods. And that's why UML came about. It was a business decision. It wasn't for the good of the world. It wasn't a theoretical modeling thing. And that probably is why it survived so strongly, because there was real business value there. Then UML 1 came out 96-ish or so, and UML 2 came out roughly 2005, 2006, and that's the only one we care about now. Version 2.4.1, if you care, came out 2 years ago, and there'll probably be another version along, in another 6 months or so. It doesn't evolve very fast now, but in my view, that's a very, very good thing. It's quite complicated enough already. Thanks very much. Because generally, the bugs have been knocked out of the meta model, because a lot of academics have spent a lot of time looking at it, and it's very sound. And now, when they're producing new versions, they tend to be adding stuff to it, which I'm really not very enthusiastic about. So let's have a quick tour of UML then. It's better to do it in graphics. So there's 3 kind of dimensions to the UML pictures. There's one underlying model of how all this fits together, but there's 3 dimensions to the pictures. There's the structures, there's behavior, and there's the interactions. And what I'm going to do is, is reasonably quickly go through these so you have seen them all, because I think that is useful. At least that if somebody waves one in front of you, you can say, haha, it's a collaboration diagram. I wouldn't do that if I were you. As opposed to going, oh, strange boxes and strange lines. Structures, fundamental structures of the class and object diagrams. I don't need to explain these, I'm sure. The class diagram, fundamental kind of object-oriented modeling, static structure of classes. It's quite sophisticated, and I'll talk about that later, about why you might not want to use every feature in it. But it reflects object-oriented programming represented in models, and there's nothing very radical about it. The object diagram, I don't know if you've maybe come across these. People tend not to draw these because they're much harder. You have to think quite hard when you do these. These you often don't have to think too hard. So people get to here and think, oh, the hell with this. I think I'll do something else. The object diagram is instances. This is classes. You get the difference clearly. In this case, I have a birthday cake ordering factory is my example, because I needed something we would all understand. So here you've got an actual order, an actual customer, 2 actual order items which reference particular products. So this shows you actually how your static diagram will come to life if you ever use it. And I find that these are actually quite useful sometimes for discussing the complicated cases, where you sort of think, how many of these will I have? And if I have 4 of them, how will I relate the 4 to 2 other entities? And you suddenly realise you haven't got enough information in your model to navigate from 1 to 1, and you suddenly realise your domain model is wrong. When you glance at the domain model, it all looks very credible, because the lines all join up. But because you don't know how the instances will necessarily join up, you're not quite sure if that's going to work. Clearly, for cake ordering systems, it's not so difficult, but your domains, I suspect, are a bit harder. The other thing about classes is classes have attributes, as you would expect, and if you want to be entirely wrong-headed, that was an opinion, then you can add operations to them, which I think is nearly always a very bad idea, and I'll talk about that later. Then the other structural things are the higher level. What a terrible term. Could mean anything, couldn't it? By which I mean generally the compositions of the simpler ideas. The component diagram, which I use a lot. So component is a concept in UML that's gloriously undefined. I can't even remember the definition. It's a long time since I read it. It's not useful, though. It says something with an identifiable boundary and an interface. The point is, we can repurpose component to be what we need it to be in our particular domain. And I'll talk about that in profiling. That's really important. If you ever see a diagram with a UML component on it, with the stereotype says component, just point your finger at the component and say, what on earth is that? Because they haven't defined it. That means nothing. And I've deliberately put it on the diagram in generic UML form. Component could mean anything. Could mean cluster of classes, could mean computer system, could mean .NET assembly, could mean an assembler module running on the mainframe. We just have no idea. And as such, it's almost useless as a piece of modeling. It doesn't communicate enough information. However, components, the good thing about components, we will fix components later, we will come back to them, but the good thing about components is they expose interfaces. They don't have to expose interfaces, that's up to you. But if you want them to, they can expose interfaces. And that's pretty important. You're all very familiar with interfaces. You've met many, many classes in your life that expose multiple interfaces, and I'm sure you've met network services where you didn't know what the implementation behind was. And that's how we represent those kind of structures, is that we have a shop repository, probably some domain-driven design kind of stuff going on here, and it exposes 2 interfaces so that the order processor doesn't understand what the component structure is. Packages are an extraordinarily generic UML term. In fact, they're even used by the tools themselves for organizing the models. So absolutely everything in UML can go in a package, and all the packages is a hierarchical nesting of groups. The nice thing about packages is that many things in computing are hierarchical nesting of groups. And so they can actually represent many, many structures, again, if you stereotype them, which in this case, you don't know what web UI is, do you? It's just a package. It's got stuff in it. We don't know yet. So we'll have to see when we get to that slide what we do to fix that. And finally, there's the spawn of all there's the collaboration diagram, which I used to think was terribly clever, and then I talked to a couple of people who really knew UML and realised maybe it wasn't quite so clever after all. It was really introduced arguably for the MDA people, because they needed a way of describing complicated structures such that they could do code generation of it. Has anyone ever seen one of these in a real design description? Yeah, I don't think I have either. I've done them on courses a few times. I've even taught them, to my shame. But I was young and impressionable. They were paying me money. You know how it is. I would say that these are generally not tremendously useful. The main thing is they tend to confuse people as to what they're looking at. Do you know, actually, when you look at the collaboration diagram, can you guess intuitively what you're looking at? Can you read enough of it? Because I think it's quite confusing. There's a thing called order a cake at the top. So it sounds like it's some kind of scenario or situation, but it's got class instances in it. And it's got another order a cake in the middle. So I'm not quite sure what's going on here. And seems to have role names. So actually what it is it's not a structure, really. It's showing it's a bit like the object diagram, but much less focused. It's trying to show how a set of instances of classes will collaborate in order to achieve a goal. I don't believe that's terribly obvious from the notation. And also, I've not found these to be tremendously valuable in actually explaining that. Even when people get the diagram, they still look at it and go, yeah, and your point is? I still don't really get what you're trying to communicate to me. So having done that one to death, we can move on. Then having developed software, a la my talk yesterday, we need to get it into production. So we'd better be clear where it's going to run in production and what kind of production environment we need it to run on. And that's what the deployment structure diagram stuff is all about. So UML's got slightly odd approach. I don't know if you can read this actually, because I've realised the one on the bottom right is a bit too small. I hoped I'd kept them all big enough, but I haven't really. UML, again, a bit driven by the MDA people, has got two sets of elements which look exactly the same, except they tend to be drawn in different colours, and they've got different stereotypes if you look closely, but they're the same shape. This is showing a pattern. So this is a pattern for deployment. It says there will be load balancers, and they will connect to compute servers, and they will connect to database servers. Strictly speaking, that diagram does not actually say how many of any of them there will be. Now, in many systems, actually, that's just what you want to say. You say, I'm n-tiered and I've got load balancers at the front, and that's fine. If, however, you actually want to say, I've got 3 of these, and actually, I've only just noticed this is quite interesting. I'll come back to those numbers in a second. You draw an instance diagram which says, so you create a node instance for every physical node, for every compute server, same for the DB server, and so on. So you actually say, I've got 4 of these and 2 of these, and you join them together. I have found in 99% of cases, this works really quite well. When you get down to instance modeling, oh crikey, you're using the wrong language. If you need to describe a data center, a UML model is not the place for it. That's what CMDB is for. So maybe an Excel spreadsheet, maybe a wiki table, but putting a large deployment into a UML model is actually a bit of a waste of time. One interesting thing though, just about models, I've genuinely only just noticed this. Do you see it says 1.2 there? That's clearly UML cardinality. It's saying the load balancer connects to 1 or 2 compute servers. It's funny actually, the tools work that out because of the instances. Because I created instances of the compute server and that I created an instance of the load balancer, it's figured out that because I've got 2 of these, then it's worked out the cardinality. Now, except in this particular case, that's not earth-shattering or indeed particularly useful. But it does show that there's a database under here, somewhere over here, with all the data in it. And it allows the tool to infer things. So, for example, things that the tool can do is it can do things like sorting and transitive dependencies, and it can do complexity analysis and those things because it's actually got the data. Then there's the interaction stuff. You've probably all drawn these before, possibly not one quite as involved as that one, but this is where you put boxes on the top of lines. What the typical process here is you draw boxes at the top of lines and put vague kind of text in them, things like store and cart and customer. At this stage, with most of your modeling, at this point, but by now you should have obfuscated the names enough that nobody can actually call you on whether you're right or wrong. And then you will start to draw lines between them. And it's also important not to be too specific what the lines mean. There's some kind of interaction, obviously. So buy is quite a good one, because that's obviously so general, nobody's going to criticize you. And then kind of maybe place in cart, applied to the cart thing. Again, not being quite sure if that's a class, an object, a component, or a service. It's important to stay woolly at this stage. And then normally people draw these dotted return arrows back again, and normally helpfully leave those unannotated, because they don't actually know what this does yet, because they didn't know what this was after all. So the chance of knowing what this interaction was is 0. So it's very, very important to leave these blank, because otherwise the person reviewing the diagram could point out you were wrong. So that tends to be how these are developed. To be fair to the originators of UML, that wasn't what they had in mind. They were actually thinking we could be a little bit more precise about it. This one is in my cake store again. And it's the lifelines are meant to be instances of things in your model. So strictly speaking, they're things called named classifiers. But let's ignore I said that and move on. That's a bit of UML geekery, really. The point is, there's something that has behavior, really. So in my case, they're classes. And I'm using it to show interactions between classes. But you can use the same diagram for interactions between components, which of course you would define what the components were, or even for that matter, data centers if you really want to. And in this case, because they're classes, I have gone against my own principle and I've started modeling operations. Generally speaking, well actually I don't know, maybe I'm being unfair, but generally speaking, lots of these diagrams at class level I tend to find just confuse people, or not necessarily confused, but they're kind of repeating what's in the code and people find them hard to keep up to date, and people do sort of draw them a bit like this, and they're not maybe as useful as they could be. At a system level, how you would process a request in a complicated n-tier system with a cache in the middle, from coming in to something going out the back, that's actually pretty valuable to explain how something comes together. And I'll show you how I use those a bit later. Worth noting, UML2, God help us, introduced a kind of pseudo-programming structure into them, based on some very respectable computer science, which I won't bore you with, mainly because I can't remember what it was. But they've introduced loops, and there are various branching and control structures, which if you insist, you can overlay onto the diagram. I've never used one of those for real, because I think that was absolutely introduced for code generation. I've never needed one of those for system level stuff. The other kind of interaction diagram, you can kind of draw the same thing but flat, sort of laid out. The reason you do this is often because these become unmanageably wide very quickly, and you can't fit them on the page. And so it's perfectly, I mean, it sounds trite, but actually it's perfectly reasonable to look for another notation you can fit on the page. These diagrams, where you have instances passing messages between each other, and these two came out of, the reason you have both of these is that they came out of different core methods back in the day when they formed UML. So neither of the gurus wanted to back down and say that their notation wasn't the right one, so they went, to hell with it, we'll put both in. Actually, it's probably not such a bad thing that it happened. This one is quite useful, but actually, when you intuitively slap something in front of people, I've found time and time again, they recognize this one and understand it without needing it to be explained. This one, you've got to explain what it is. And there's arguably not enough visual differentiation between it and other diagrams. Yes, Rob?
On the right-hand one, you have to number the arrows then to get the sequence?
You do have to number the arrows, or of course, say, UML will do it for you as you draw them. In fact, Magic Draw has done this. Oh, dropped its name. Doesn't matter. I use Magic Draw for nearly all my UML. I'll talk about tools very briefly at the end. So when I drew that line, it put a 1 on for me. And when I drew that line, by default, it inferred that I was probably continuing from order. So it put 1.1 and it put 1.1 and so on. And then you can right click and say, no, start again. And it'll say, oh, this is separate, and starts 2. But you're right. That gets a bit fiddly, particularly if you haven't got something renaming for you. This in Visio is like pulling teeth, because not only do you have to get them right, but then you realise you've missed one, and you've missed 1.1, and you've got a 1.9. Oh, how painful is that? Another reason why actually drawing very detailed models in drawing tools isn't necessarily a good idea. But the point of these is they bring your model alive, because after all, when you give people one of those, how does it work? Absolutely no idea. This stuff knows about stuff, and stuff's got operations. Really? I mean, what's going to happen if I want to buy a cake? Just no idea. Whereas, do that, and suddenly how an order drives the process of buying a cake becomes a little bit more obvious. There's then the interaction overview diagram. I've never used one of these in Anger, but I did say I'd show you them all. All it is really is a way of structuring infeasibly complicated interactions to fool the viewer into thinking that actually you understand them. That, I think, is their main purpose. It allows you to put effectively fragments of interaction inside boxes and then relate those together. Should you ever be tempted to go near one of these, if you think, you can do this on the train on the way home, if you draw yourself even quite a simple one, but make sure you've got at least 2 or 3 states in each compound state, as they're known, and then draw a non-trivial control structure between them, just try and argue out the semantics for yourself before you get home. You'll need quite a long train journey. This diagram's got very subtle semantics, if you care, and you need to be very sure you understand what you're saying. And that's, as I'll talk about later, keeping your UML models simple and using the simple diagrams we all understand is actually crucial to communication, as opposed to being clever or trying to look clever. Which I have known a number of architects that will remain nameless in years gone by, where I'm quite convinced their use of UML was to impress their intellectual superiority on the room, rather than to actually communicate meaningful information. Then there's the hated by me use case diagram, which I will come back and do the character assassination of that later. But suffice to say, it has undefined things in the middle, which are called use cases. But the standard very helpfully doesn't tell you what a use case is, other than a one-line definition, or indeed what should go in one, which is nice. And then there are some rather complicated relationships you can have between them, again, if you really, really insist. And then the easy bit, you can have actors, computers or people or whatever, that interact with your system, and which use cases, system interaction points they want to use. it looks really straightforward, and people seem to be utterly, even people who hate UML seem to be utterly addicted to this diagram. It just bewilders me. Like I say, I'll come back and try and destroy it for you later. Apologies if you really like it. These things happen. Then there's the state machine. Clearly, if you've got a computer science degree, state machines are not going to be new to you. In fact, if you haven't got a computer science degree, you've probably met them many times. UML has a very, very powerful state machine notation, which I would encourage you to use the basics of, and oh dear, and make sure that you never, that's my daughter, that you never go near the complicated end of it, because it has semantics complicated enough that you need a computer to understand them. And there are really some quite sophisticated software programs out there to help you understand them. But clearly, if you need a computer to explain your design back to you, something's gone wrong somewhere. Activity diagrams are flowcharts for the 20th century. I was on a UML course aeons ago when UML 2 first came in, and I can't remember his name now. Terribly nice chap who runs his own consultancy in Wales, who was doing this for the IET, and he presented activity diagrams and then spent the first 15 minutes of the talk trying to persuade us they weren't flowcharts. And he was utterly unconvincing by the end of it. So we all kind of looked at each other and went, yeah, flowcharts, aren't they? But we were all much happier for it, because then we understood what we were looking at. They are basically flowcharts. They've got some decent semantics and some quite sophisticated structures. And there's nothing wrong with that. There's nothing wrong with a flowchart. That's what we were trying to persuade him, because we all were starting to get grey hair. He was clearly thought in some way flowcharts were embarrassing. Nothing wrong with a flowchart, because after all, if you've got a number of things that happen as part of a process, it's rather nice to be able to work out what order they happen in, what data they exchange, and who does what. And that's a flowchart. So these you've probably met. These vertical things are called swim lanes, and they indicate which actors perform which steps in a process. Like BPMN, UML activity diagram, unlike the state charts, UML activity diagrams can get complicated to the point where they almost become meaningless. And that's the big thing to keep avoiding, is things going wrong. It's also very important to know what these are. That's called an activity. I'll give you a clue. The hint's in the name of the diagram. The snag is that you don't need to define an activity in any way. You can just plonk one on a diagram, and your tool will helpfully create an entry in the database for an activity called place order. You don't need to tie it to anything. I mean, you can, and in fact, these are use cases. Well, these are tied to my use cases. That's why they've got the same names. But it's quite common, I find, that especially when business change type people, do you all work with business change, or even worse, project management office, PMO people? They really are something, aren't they? Yes, there's no feature of PowerPoint those people have not explored. They tend to draw diagrams that look like this, and they can be put into a UML tool and sort of smartened up and made to look really quite respectable. Until actually when you come to them and say, so accept order, just lead me through that. They go, well, you know, we kind of accept the order from the client, I think. And you think, you have no idea what that means, do you? And they go, no, not really. So actually, you've drawn a diagram full of concepts you don't understand, related together by very precise semantics. I mean, really, where's the value in that? So early on, you've got to be quite clear you actually understand what's in the diagram. So that's what UML provides out of the box. And it's all pretty generic, isn't it? You know, component, class, you know, association. It's actually not very tied to the kind of things that we actually use in our systems and in our businesses. However, a very, very important part of UML, which actually you can do many UML courses, and they won't even mention that this exists. A very important part of UML is called the profiling mechanism. Actually, UML uses it itself in defining some of the language. The core language is smaller than the language you're taught, and some of the language uses profiles to extend it. Profiles are an extension mechanism. If you create a model in base UML, there's an awful lot of guesswork as to what the person really meant. So you've got to put an awful lot of text with it, typically, to say, this component here and this component here represent different kinds of things. So, and this was one of the problems with UML 1. It had no formal mechanism for solving that problem. But UML's actually got the ability to create a domain-specific language entirely in UML, entirely based in UML, that can be stored in a UML database, which is really quite cool. And this mechanism is called profiles. Now, profiles are quite, well, they're not a big and complicated feature, really. They're a bit bigger and slightly more complicated than I'm explaining, but all you need to know is the stuff that I'll explain right now, which is really straightforward to do. There's nothing complicated in profiles at all. Should you want to introduce things into your model of a specific type, then you want to be able to say that a component, for example, is not a component, it's a Spring service, or it's a I forgot the name of the Microsoft product, the Microsoft Workflow Manager workflow, or something else rather tangible. And so, for example, you might say that in my world, I've got Java components, and there are a number of types. I have POJOs that I sometimes want to talk about. I have Spring services that I sometimes want to talk about. I have EJB, stateless session beans. I have stateful session beans. I have servlets. And all of those things are things I want to talk about. I want to put them in models, and I want people to understand them. And you'll notice this is actually a UML class diagram of sorts. This is what I've done. I have created a UML class diagram of creating elements on it called stereotypes. Now, I won't go into the meta model. It's really not that exciting. But all you have to bear in mind is that stereotype is part of the language. It kind of comes with UML, and it's kind of based on itself. It's all a bit kind of brain-blowing the way that they decided to put it together. But what I can do is I can say there's a kind of thing which, and it's effectively a tag, which I want to apply to UML model elements of a certain type. So for example, Spring services, I want to attach to things of type class, and EJB stateless session beans I want to attach to things of type component, to specialize them. And if I don't care, if I want to be able to attach it to anything, then you say that you can attach them to this magic type called named element. That's the bit I'm not going to explain. It's a thing. It's an important thing in the UML meta model. Everything else is a named element. It's like, it's java.lang.object, but in UML. So stereotypes allow elements to be specialized. So you can now start to get a bit precise. You put a component on, it's not a component, it's a Spring service. And you can be specific about that. And a profile, all a profile is, don't let the big brain people fool you, all a profile is a bundle of stereotypes. It can be more as well. Yes, it can be even more fun. But basically, it's a bundle of stereotypes. And what they do is they allow you to create your own domain-specific language. And most decent UML tools these days allow you to create profiles and allow you to create palettes of profiled elements so that you're not dealing with component and class, you're dealing with Spring service, servlet, and EJBs, or whatever it is makes sense in your world. The point is, these are very generic, because this is a public talk. If I was at UBS, I've got lots of stereotypes very specific to us, our middleware and our systems, because they're important that the engineers that I'm working with understand it's those things very specific to us that I'm talking about. So they're part of the meta model. That's really the point. They're built into the language. So this is the kind of plain model, no profiles. And what is it? I realized after I'd finished the slides, I've given you a bit of a hint because I called that Tomcat container. That's just a name, not stereotype. So this is probably Java stuff. But actually, what are the parts? You don't know as to what those components are, and you don't know what the relationships are, in fact. And indeed, cake schema, you can get a hint because, again, I left the name on. It's probably a SQL schema. OK, I'll give you that one. But the fact it's a SQL schema is not in the model, so you cannot ask the model, how many SQL schemas do I have? Because it doesn't know, because it just knows you've got a thing called an artifact. Whereas, if I stereotype it correctly, and one of the things about stereotypes is I can associate an icon with a stereotype, so then when I apply a stereotype, the picture changes. You see? I had a cake schema, which was a square box. UML has a lot of square boxes. You may have noticed that already. And they're differentiated by small symbols in the top right-hand corner, which is not necessarily great. In this one, I get a much more sort of visually pleasing symbol, which looks like a database. And over here, I've stereotyped things quite precisely to say that's a servlet, our servlet, and this one's a POJO, and those are POJO services, and that's an EMS publish subscribe topic. I haven't added topic on to keep it an acceptable length. But now I can see that this thing and this thing are collaborating via publish subscribe, and this servlet uses POJO services, presumably wired together using Spring. I mean, I could be more specific with the stereotypes. But now, when you read that as a developer, you've got a pretty shrewd idea how you'd go and build that. When you looked at that one, you had absolutely no clue what I was talking about. So that's the point. It's a Java web app. Hurrah! The other thing about stereotypes is if you don't change the icon, the kind of two ways to look at this, if you don't change the icon, less technical users or people who aren't as interested in the detail tend to find them very easy to ignore. That's just an observation I've made over the years. Sometimes you do want to be quite precise and pernickety about things, and you put very specific stereotypes on. Actually, I found that people who don't care just kind of read past them, which is actually quite useful, because some people will care and some people won't. Things that you want to watch when you're creating profiles. Firstly, agonizing them on meta models. There is something about software developers. If you say create a meta model, well, there's two sorts of developer. One goes, to hell with that, I'll be off and do some coding, see you at the end. And the other set goes, fantastic, well, let's get started. And before you know it, you've got whiteboards covered in abstract concepts with complicated relationships between them that you don't understand, and you're not entirely sure they understand either. A profile shouldn't be hard. It should be a 20-minute exercise. What have we got? We'll be needing to collect maybe a couple of them into a couple of inheritance hierarchies. We're done. The other thing is worrying about graphics. We've headed down some right blind alleys about graphics and picking the right icon and producing icons that work well in tools. There's something called iconfinder.com I discovered a few months ago. They've got SVG icons. Stop there. Pick an icon, shove it in your tool, you're done. The other thing is if you use shocking graphics. Somebody a few years ago, who's quite a good friend actually, informed me that my graphics looked as if they'd been done by their 4-year-old. I thought, well, thank you. I slaved over that SVG. I thought it was rather impressive. He was right though, actually. When you printed large pictures out with it, it scaled terribly. And actually, really poor graphics create a very bad impression. So if you can't do it, leave the pictures as they are. The other thing you can do with stereotypes is you can add in attributes or operations that everything with that stereotype has. I'll show you how to do that later with nodes. One of the things you could do, if you have a compute node stereotype, you could have a number of CPUs attribute in the stereotype. When you apply that stereotype to a node, it will automatically get that attribute, and then you can enter that number into the model should you want to. Again, this is linked to the meta-modeling thing. Give people a tool, and they just love, once they've understood it, to get right into it. And they'll end up with lots of intricate stereotypes which you'll never use. Keep it simple, stupid, or something. Making sure everybody understands your profile. This is the trade-off, right? As soon as you extend UML, you have to make sure everyone understands your extensions. So that said, they've got some basic stuff to start with, but you do need to explain it to people. And then the other thing is there's an awful lot of UML tools out there. 90% of them are not worthy of the name, and they're actually drawing tools that happen to have symbols that look not unlike UML. There are some very good UML tools out there, but if you assume that the sort of not really UML tools support profiles, you will be in for a nasty surprise. It's only the real UML tools support it. The reason is you need to support the meta model, otherwise the profiles don't work, because the profiles are all based on the meta model. And like I say, 90% of the tools are not UML tools. They don't have the meta model. I don't endorse any of them, but if you want my particular biases, you can talk to me afterwards. So, the good bits. First thing is about creating effective models. You've got to ask yourself 3 questions before you start modeling. Who cares? And if the answer is no one, stop. What do they want to know? And if the answer is I'm not sure, stop. And what will they understand? And if the answer is damn all based on experience, stop. Because if you don't know who cares, what they want to know, and what they will understand in terms of representation, no point building a model, is there? Now, it's perfectly okay to say, who cares me? What do they want to know? I'd like a detailed architecture model, please. What will they understand? I know UML2 really well. That's absolutely fine. You're your own customer. If you can justify the time, there's no harm at all you being the customer. But if you're not that bothered about having a detailed architecture model, and nobody else is, clearly that is not a fruitful direction to pursue. You're all looking at me as if I'm kind of mad. It is sort of true, except that I feel a bit like Tom Guild now. I'm going to start shouting at you. Is that actually I find lots and lots of models, even sketches in Visio, done without any of those questions being asked. People put pictures in front of each other all day and go, you see, it's obvious. And the other person goes, yeah, whatever. And there's been no meeting of minds whatsoever. And then enterprise programs are started because somebody thinks that they've got endorsement from somebody senior who didn't understand that they were even being asked about a program. It's a very common anti-pattern in organisations. So John Daniels, who's a very distinguished UK software engineer, who's a great modeler actually, who's very, very good at doing all this stuff, though actually does a lot less of it today than he used to. his catchphrase is model with a purpose, which a lot of people have then stolen since. He used that catchphrase at a conference in the late 90s, I think, maybe mid-90s, and people have stolen it ever since, but it was John Daniels came up with it. It's a lovely slogan. If you haven't got a purpose to build a model, don't build a model. So who cares? Here's the kind of cares that I have noted. Developers care about the business domain, so they need a domain model. They want to know the boundary of their system and what they'll interact with, and that's a context diagram. That's not a UML diagram, you'll notice. That's one of the ones I referred to. That's an Eoin diagram. Well, it's not really. I'm just stealing ideas from 25 years ago. I'm hoping you won't have seen before. It's a very common diagram in lots and lots of approaches, but for some reason UML didn't include it. So I've just recreated it. How does the system work? That's typically components, actually defining what a component is, and interactions. How do they communicate between each other? And then the code structure. What dependency should I have between different parts of my code? The operations group, or production services, or whatever you call them, people who run the system, they tend to care a lot about the context diagram because they really want to know what you're dependent on, what you're plugged into, and what's going to happen if an external system fails. And they also want to know how it's installed and deployed. Now, there's a lot more than a UML model they need, but actually deployment models I've used with production services at various points, and they find them tremendously valuable because to them it's a level of precision and definition which they're just not used to getting. Because normally they get lots of shrugging of shoulders and, well, we'll put it on Linux, won't we, like all the others, and we'll kind of use Oracle. And they're kind of going, yeah, we know, but how much and what and where and which data center and what's going to be linked together? And are you absolutely sure that this is going to work if something fails? I mean, it's all those questions which, if you've got a deployment model, they actually, I find they're one of the most enthusiastic stakeholders. They'll really work with you to understand the implications of it. And then users, they need a domain model, and they need to understand how the system will be used for real problems, so activity diagrams. They may well not respond well to detailed UML models, and this is why having a model and many representations of it can work very well, is that you may well, in fact all three of these groups, and other groups as well, may need their own representations, but one source of truth, the dry principle, don't repeat yourself. You've said it once, just represent it different times. So that's my picture. So developers really want all of the stuff that I'm talking about here, and operations and end users want some kind of subset of it. The green ticks came from Icon Finder. It really does exist. System context diagram. It's not a standard UML diagram. I don't really understand why, but here's how I draw one. This is sort of adapting UML. So you start with the UML component diagram. Do you remember those component diagrams with components and interfaces and all that stuff? This is a trivial component diagram, but quite an important one. So you create a single component, and there is a standard stereotype. You can create your own, but there's one already. Stereotype called subsystem in UML, which is the one I tend to use. You stick subsystem on to indicate that this is a system and not just some piece of code. And then you create a stereotype, or more than one stereotype, to indicate the things that you communicate with outside your system. Now here I've kept it quite generic, and I actually have this one in my own UML profile. I have something called external, which is it's outside my system and I don't know much more about it, or I don't need to tell you much more about it. It's just outside our boundary. And then you create components for all the things outside your system and clearly stereotype them as external. And then you create associations, so UML associations, ideally directional associations between the two with a clear statement of either the data types or the request types that travel over them. And then it's also worth attaching your real human users to it if that doesn't massively clutter the diagram. The problem with all these diagrams is that you tend to find that in reality you won't have two of these, will you? You'll have 24 and you'll have 8 types of user. So actually you have to scale this to be awfully big just to get the sides of the shape big enough to connect everything to. That's why you sometimes need to pick your battles and decide. You might draw many of these diagrams, but remember one model. So you can show subsets of the external systems that you communicate to and connect with for different audiences, because different people care about different stuff. So that sets the scene for the entire system. A domain model. So a domain model is just a class diagram. No kind of rocket science there. Has anyone here not created a UML class diagram? Yeah, I thought not. Everyone's done one at some point. Everyone understands a class diagram, don't they? Yeah, of course they do. What's the difference? This is your pop quiz. What's the semantic difference between that and that? One?
Tying the lifetimes together.
Yep, lifetimes. What are their names? Very good. Hands up honestly, we're not going to judge you. No one's going to tell your boss. Who knew that? It's about a third of the class. You're self-selected people who build models and have all done UML before. So you're the 1% of the 1%. And you can't remember that off the top of your heads. I know you could all have gone and found the quick reference card and you've gone, oh yeah, of course, composition, yeah, I remember. But the point was, if I just throw on the diagram in front of you, you'd have gone, oh, filled diamond, empty diamond, yeah, that's important, isn't it? I don't remember. So everyone kind of understands it, but the other thing, I'm not going to flip back to it because it's too much clicking, but in my domain model, I had an association class, which is one of these slightly odd ones, drawn where you have an association and then a class hanging off the association, which again, actually, the older you are, the more chances are that you'll recognize that because it used to be in a lot of data modeling methods. And lots of relational database modelers use this quite a lot because they use it for resolution tables between many manys. So this is where you have an association, but when you have that relationship between two things, you need to store some data for that association. And so you indicate that there. Again, that's a bit of notation that I won't ask for hands this time, but you can just examine your consciences. If you throw that in front of people, generally speaking, they look at it and go, yeah, that's very good. Anyway, about this end, and they don't really know what it means. So everyone thinks they understand it, only there's lots of notation in it. Actually, people don't understand. The other snag with the class diagram, well, I'll ask you, what's the other snag with the class diagram in most UML tools? And actually, the UML tools are being perfectly correct here. What's the problem with it when you come to draw it? Remember the palette compared to the other diagrams? It's pretty big because you see class. I won't go on and on about UML Arcania, but this one is worth knowing. A class in the meta model is an awfully long way up the inheritance hierarchy. It's just below named identifier, named element. There's an awful lot of things in UML can connect to a class, can extend to a class, or can have an association with a class. So you can bung all kinds of old rubbish on a class diagram. You can put components on it, and you can associate packages with classes, and there's all sorts of stuff which is perfectly valid to do, and you can't really stop people doing it unless you use a stereotype, because it's just the way the meta model works. It was too hard to make it work otherwise. But one of the snags is people can find stuff on the palette and throw it on and go, yeah, I like the shape of that one, and they connect it up, and suddenly you've got a whole lot of stuff on the class diagram. You have no idea why it's there. So not everybody understands all the detail. So you need two things. You need notational simplicity as well as conceptual simplicity. Clearly your domain model needs to be as simple as possible. Agreed? You don't want extraneous concepts, and you don't want anything on it which you don't need. You want to do the simplest thing possible. You also, though, need to model with your audience in mind, and probably use don't assume good UML knowledge. You've probably got good UML knowledge. They probably haven't. You might well want a sophisticated domain model somewhere for developers, but there's no reason you can't present it. So again, a good UML tool will allow you to suppress all this gubbins on the diagram. You might want to present one that's just boxes with names in them, no attributes, no nothing, and straight lines. And then go and present that to your business user and say, does this relate to this? And if you've got one of these, you always have one of these, and have one of those conversations, and then just kind of use dots and smiley faces or something. And then you can come back and actually build a model. I was about to make another very insightful point, which is just flowing from my head. Oh yeah, that's the other thing. I have a rather strong opinion that if you're adding operations to your domain model, something's gone badly wrong somewhere. In domain models, generally speaking, I've found time and time again, operations massively confuse things. People will quite quickly say, customers, what information have you got on a customer? Oh, I've got a name, address, you've got an ID, you've got a last order date. Oh, last order date, that sounds a bit derived. Okay, we'll make a note of that one. But they can tell you what information there is. But you say things like, does a customer have a derived credit rating operation? And they go, maybe. And this is technical people, they go, maybe. And you go, so should that have it, or should a separate service have it? I mean, you quickly get into effectively designing your system. It's interesting, one of the really, really advanced and also very successful in its own way object-oriented methods when we had a lot of object-oriented methods, was called Fusion. It was developed in Bristol at HP Labs by Derek Coleman's team. What was striking was that they had this insight. This was the era of domain modeling up the kazoo, right? Operations and attributes everywhere, data types, structures, the whole 9 yards. And they cut it right back and said, no, that goes badly wrong. You start designing the system. And what they said was, what you need is this structure, and then if there are things like relationships and constraints, like you can't have more than, if you've got a date before today, you can't have a greater value of orders than £10. They said, that's an invariant, as they called it, because they were research people, or a constraint, as we would call it, on the model. Write it down. Don't go trying to add operations to try and enforce these things, because that's kind of what people were doing. And the reason they said it was, you don't know where the responsibilities are going to go, because you haven't designed the system yet. You're meant to be looking at the problem domain. So just describe the problem domain, don't try and put operations in. And I think they were exactly right. I read that book in, 92, and I've used that advice ever since, and it's stood me in good stead and avoided many a pointless argument. So that's domain models. The other thing is use inheritance sparingly. How many times have you seen someone get rather excited about inheritance? They've got 6 levels deep and it's 4 wide, and you just think, oh, for God's sake, I mean, really? Even worse, that suggests that either the domain is much more complicated than you thought it was, which is rarely the case, or they're going to massively overcomplicate it when they come to code it. They're only doing a model and they're 4 levels deep. Think when they come to look at the code how excited they're going to get about the possibilities, especially when they throw interfaces into the mix. So before you know it, you will have a type system no one understands. Activity diagrams, I think, are valuable, providing you define, as I said, what these actually are. These have to be real. I mean, something you can point at. They have to be like a business step that someone really does, or they have to be a use case. And it's not use cases I hate, it's only the diagram. A proper interaction with the system, or there have to be a recognised procedure that somebody in the business goes, yep, I know what that is, I can show you how to do it, here's the form. If they can't give you that level of detail about what this is, it doesn't really exist. Because what will happen is, you'll go a long way with everyone going, yeah, this looks fine, yeah, we definitely accept orders, yeah, and then we fulfill them, yeah, that's absolutely correct. And then you'll build a system with those screens and they'll go, oh, just a minute. No, we don't accept orders in your system. No, we accept orders over the phone, and then we enter them over here, and your system's got to accept the order. I didn't mean accept when I said accept. I meant, well, accept. Yeah. So you'll quickly, not quickly actually, unless you've got very good feedback, you'll find that unless you define those well, they are just a world of pain waiting to happen. Because one of the problems with models is that they give a kind of pseudo-scientific or pseudo-definition to badly thought out concepts, unless you're quite rigorous. So the model looks quite rigorous, and the semantics of the bits in between are quite rigorous, but if the activities are meaningless, it's all built on sand. And the other thing is, don't overcomplicate it. Again, look in the palette, crikey, there'll be a lot. Any decent UML tool will allow you to tailor the palette. And if you want business analysts to do this, just take out 90% of the stuff in the palette, otherwise they'll use it. And there'll be, business processes you couldn't possibly implement. Nice thing about it is it makes the responsibilities of each actor clear, and again, that tends to broker discussions, so customers cannot fulfill orders, bakers cannot check order status. Is that all right? I think probably not, actually. I think there's probably something here where bakers probably can check order status. Maybe not in this business process, but that's something that has to be discussed. And similarly, bakers can't place orders. Oh, are bakers acting as customers? Oh, I don't know. Well, they're staff. Would they belong to the system as staff? Yeah, they would. Is there anything about creating an order as a member of staff that we'd need to think about? When you've made it clear what roles are performing what, then suddenly business people tend to start explaining things to you very quickly as to why that's probably not a good idea. Yeah.
What's the flow order in this diagram? Because there are two place order, there are 2 arrows.
That's right.
Out.
Indeed.
Is it parallel? Is it separate?
It's undefined, and that's deliberate. You can define it very precisely if you want to, but in this diagram it means that a customer has to complete placing an order before either of those two can happen. But as soon as placing an order is complete, you must expect that either of those can happen. And incidentally, that's one of the notational things to be aware of in this diagram. People read it as, because we read top to bottom in English, they read place order, accept order, fulfill order, check order status, complete order. That's not what it says. It says place order, then accept order or check order status, accept order, check order status, fulfill order or check order status, fulfill order or check order status, complete order or check order status, complete order or check order status, indefinitely. You, again, this is where learning the semantics of the diagrams is quite important. If you want to parallelize it, or you want to force it to be single-threaded, all the notation is there in the diagram, using the bars.
Why not putting a fork there to make it much clearer?
You could do. People tend not to when they're dealing with business people, I would say. And in this case, I don't particularly need to give a fork because, what I'm saying is these are separate streams of activity that happen after place order is complete. And the software developers need to understand that. If you put the fork in, the only snag is that that's another symbol people have to understand, semantics. And as soon as you bring it to less technical people, there's yet more kind of barrier stuff to explain.
But it makes it clearer. It makes the semantics more clear. So that's my opinion.
I actually don't disagree with you. I think it's absolutely fine to add a fork if that makes sense in your environment, and people will understand it. I say my general principle with all this stuff is I minimise the number of shapes I use while trying to stay precise, and I'm quite clear what that means because the notation is defined that way.
The trade-off is that you have to explain more.
Well, maybe I do, but I don't know. I think it depends on your stakeholders. But yeah, perfectly fair point. On the functional structure stuff, we've had a little look at already. So this is when, as a system designer, you know what the structure of your system is going to be, and you need to start communicating it to people. In particular, what moving parts do you have? What dependencies do they have between each other? And perhaps what interfaces? I've not shown interfaces on this because as soon as I added them and I needed to lay the diagram out, it just became too small for you. I figured the text was going to shrink to the point you wouldn't be able to read it. But we could, I showed you it earlier, the lollipop notation, we could have interfaces out of all of these services to show the specific interface that they export. We don't have to though. That's not a requirement of the notation. It depends whether that's useful for you or not. In many cases, of course, in real systems, you end up with a thing called repository that exports an interface called repository. I've drawn an awful lot of those where you just go, this isn't adding a lot, is it really? There's a repository, it's got a single interface. I think a users relation is fine. So in this case, what I'm doing is I'm creating components to indicate the physical parts of my system. Now, physical depends very much on your environment. What I have tended to find is that when you're using almost any enterprise technology, there is some concept of a piece which has independent configurability or lifetime or boundary, and those are probably the things to create components for. That said, this is at quite a detailed level, so depending on your system, you might find, certainly in our systems, we probably wouldn't model at this level because we've just got too many services. We would use rather higher level components and give them different types. But you decide what the types of thing in your technical environment are, and you create stereotypes to support that. And then you create components to represent the things that are going to be in your system. Stereotype them appropriately to make sure that you are defining what the real technical instantiation of this is, and then define their dependencies. There's a couple of ways to do that, but really the one that I use time and time again and seems to work quite well is just simple, the most generic connection UML's got called use, and that's just a dependency. You can stereotype that as well. I've actually stereotyped that one there as a JSON over HTTP, which is worth somewhere defining what your stereotypes mean, obviously. It'd be kind of ironic to have lots of stereotypes you didn't know what they meant. But a users relation is actually a good start if you want to keep things simple. It just indicates clearly the web service has no knowledge of these two, but it does need that, and it also needs this piece of middleware, or this middleware topic. So as well as pieces of code, you can represent pieces of infrastructure or pieces of, or sort of communication mechanisms. And then I'm using packages here For some reason, that slipped inside the shape. I don't know what I did there. I've used packages here to indicate deployment contexts. Now, again, that's a convention that I use repeatedly, and I found very valuable, because it helps people to understand how the qualities the system's likely to exhibit, and it helps them to start seeing forwards to how the system will look in terms of its runtime structure. That said, this is an Eoin convention. This isn't part of UML. You need to be quite clear what your conventions are, but I would suggest, if you're starting out, this is a good one to do. Use a package for your runtime contexts, use components for all the tangible pieces of your system, and I have to leave you to figure out what that means with your technology, stereotype them to make them clear, and then use users relations to indicate how the dependencies flow between them. And make sure you don't forget all the mechanisms used to communicate between things. They need elements on the model as well. I actually use classes for those because they're not really components in any meaningful sense, but that's actually that's a simple preference rather than anything else. Yeah. Maybe I should start using my own annotations. Once you've got a functional structure, like this one, the problem is that you can't actually tell how the bits work together in order to achieve a meaningful goal. So that's when, now I wish I hadn't done the animation, that's when the interaction diagram is useful. And you will see these things at the top are my components. They've been dragged from one diagram to another and just dropped, and the tool's gone, haha, I know about that, and it's created lifelines for each. At this point, I'm now starting to get reasonably specific about what's actually going to be passed around between them in terms of invocations or service calls or data. At this point, you should be precise enough somebody can say, when you say save order, I didn't think we had an operation called save order on the repository. I thought we were going to use implicit saving or whatever. That's probably not one they challenge, is it? But you know what I mean. At this point, you need to be specific enough that these names tie up with the service interfaces that you actually plan to offer. Otherwise, again, this just becomes rather woolly. And if you're using returns, and that return should be dashed, should it? No, sorry, that's an invocation. Yeah, when you're using returns, again, you need to make those tangible. That in itself is a bit woolly, isn't it? One of the problems with, you don't need to show the returns. Add the returns when they're adding more information. The main reason I show return on these diagrams is because either I need to get a bit of information back, which is used further down in the structure, so it's used there, there, and there, or I need to show that some piece of information or interaction is happening that probably triggers something else, because that helps people understand how control flow works through the system. And then constant problem with these diagrams is how many of them do you do, and when do you do them, and who uses them. I tend to do, so for a structure like the one I've just shown you, which I'm not going to go back to because of the animation, I would tend to do one of these for a happy day case, and one of these for an error case, and then go and discuss them with people who are going to build it, and they'll ask you lots of questions. And some of those questions you can point to your existing diagrams and say, here's what I meant. And in some cases you'll think, that's a very good point. Either that's not possible, or I simply haven't shown that yet, and sort of be demand driven. Because you can draw dozens of these, and actually many of them are showing broadly the same thing. They sort of end up being an equivalence class, really. So you need to make sure each one, because each one is effort and maintenance, each one actually shows something new. Deployment. Remember I said there's two aspects to deployment, so I nearly always used the deployment patterns. I've very rarely found that the instances are terribly valuable. I will show you one in a minute, but the deployment patterns show the kinds of infrastructure you need, not the individual machines, and they show you the artifacts that are going to come out of your build system and where they're actually going to be placed. They also show which bits are connected together. Now, this isn't a specification for the network team. It's more a sort of set of high-level requirements for the network team. For this kind of system, it's kind of obvious. These things need chained together. But if, for example, you've got something external here, and it's connected to it, that's probably quite a big red light, which it's worth having that discussion with the production team very early. We're going to need a brand new Swift connection out of the organization to so-and-so. Even if they don't need to put more physical networking in, they probably need to commission some kind of connection in the Swift network, for example. Within a data center, you kind of assume everything's linked together, but the value of showing these is that you can highlight any requirements you've got of them. And also you're clear which machines need to communicate with which other machines. So if you need to have discussions about where you're going to put stuff, we have, for example, 2 London, very, very large London data centers with many, many rooms in each. And for some of our systems, whether this is beside this is actually quite critical. And for other systems, we can actually spread the bits around. We spread them between the data centers. So showing the required links between things, and if necessary, highlighting using color or tags or notes as to which are the latency sensitive ones, allows you to have those kind of conversations with the infrastructure team. As before, if you stereotype quite liberally, then people will actually know what you're talking about. So this kind of runtime container and so on. There's a specific pattern for how to do this bit, which I'll show you in a few minutes' time. So the key things are show the hosts that you are going to need to run your stuff on. Be clear if you need an execution environment on that host. That tends to mean a software container, but not necessarily. So do you need an Oracle database to put your schema in? Better tell someone. Do you need a Tomcat container to put your jars in, or are they self-contained? And then packages can be used for anything you need them to be used, really, but I tend to use them for packaging up to show physical locations of machines, where I need stuff to be, or where I'm being forced to put stuff, because we haven't got space in one area. And that can be quite important. The way that you show where your code is a UML thing called an artifact. Artifact, how general could you get? All it means is a physical thing related to software deployment. All I do is, you know what comes out of your build system. It might not be at jar level. I mean, maybe it's at, some more abstract level, but you know the packages of code that come out of your systems. So you need to be clear where they have to go in the deployment environment. Once you've got a system up and running, this is all kind of obvious, but before you've got a system up and running, or when you're making a big change to your deployment environment, this is a useful thing I've found to overcome unfortunate assumptions people are making about where their code's going to be. The instances I mentioned earlier, I don't really use these, but for smaller systems, and I have seen people use these and get a lot of value out of them, you're being very, whereas that's a pattern, this is the specific set of instances that you actually want to run on. So that's a specific compute server, that's a specific Tomcat server, and so on. And you actually link them together to show how you need them networked. I suppose the key thing is, if these diagrams become a bit big and a bit awkward to use, you're probably using the wrong tool, as in not UML tool. UML's the wrong tool to do it. I find all the systems I work on, there's just too much of this to stick on a diagram. And actually, I don't get great payback putting these in a model. I don't particularly want to ask questions about these, and if I want to ask questions about these, they don't tend to be the kind of questions I want to ask a UML model. I need to go and ask the production configuration database, and we have production configuration management for that. It's just a different. Ideally, it'd be nice if I could link them together, but which I don't today. But I think this is really a different problem, and again, I think it was probably driven by the MDA initiative, where they needed to have absolutely everything in the UML model so they could generate absolutely everything, such as deployment descriptors and so on, which I just have no interest in doing at all. It did this yesterday. It clicks for a while, and then just when you're getting a bit confident, it decides to not click a bit. Then there's module structures. So this is what a lot of people think of as software architecture, actually, which I think is really one dimension of it. This is the code structure and what can connect to it. Oh, sorry, not connect. What can rely on what? Generally, what I'm showing here is modules or layers, and actually, I tend to just use UML packages because I'm not trying to do anything very clever or identify clever semantics or anything. All I'm trying to show is the fact that in this case, the web UI is the top conceptual layer, and it can depend on utilities on the cake server. The cake server can only depends on utilities and the domain and the domain utils, and domain depends on domain utils. No rocket science there. But if you don't write it down, again, nobody actually knows what they were expecting. That said, this is kind of useful relatively early on when you're planning a code line. You sort of say, here's what we're going to need, here's the modules I think we'll have, and here's the dependencies we should have. As soon as you've got a big chunk of code, I wouldn't be modeling this in UML, I'd be using a proper structural analyzer to figure out what the real structure is. Because it will show you this, but it'll also show you the fact that domain has become dependent on the cake server by mistake. So Structure 101, Lattice, Endepend, all those kind of tools do a much better job for this once you've actually got a code base. One final model, which it's worth talking about briefly, is the application landscape. This is more an enterprise architecture model, but I'll talk about it briefly. UML has something that hardly anybody knows about called information flow. You would have thought it would be up front and center, but it was clearly pasted into the spec quite late into UML2, and it's in an appendix, believe it or not. These are useful for application landscapes. So I have applications, and they communicate via by exchanging certain information. Key point about this, the reason it's not just Visio, is that again it's tied to a model. These types that go across the flows are real UML classes. If I rename order here, it will be renamed on all the diagrams where it's used. Similarly with the applications, if I rename the execution system, it'll get renamed in all the places it's used. You just don't get that with the kind of Visio approach. With the Visio approach, you're constantly having problems with consistency. So a few patterns which I use, which I think are quite useful. Functional structure pattern, this is the one that we've seen a couple of times. So it's a highly constrained component diagram. This is the one we've talked about already. So you use packages to show deployment structures or containers. You use heavily stereotyped components to show your components, and you make sure you know what that means. And you optionally use interfaces, if it's useful, to show dependencies. The execution environment one, I'll just briefly mention. I've created there a stereotype called server, which is obviously some kind of compute server. And it's got some, strictly not attributes, they're called tags, but it's got 3 standard tags associated with server: CPU, memory, and model. Every time I stereotype something as server, it gets those 3 tags added to it empty. And so I can define them or not, as the case may be. I do this quite a lot to indicate the kind of deployment environment I'm expecting to put a system into. Then you use something called an execution environment, which is in the meta model, it's a subtype of node, to indicate your runtime software environment, and then your artifacts indicate where your code goes. And I find it's really simple, and it's really quite effective. You do this for each of the kind of nodes in your system, you show how they're linked together, and bingo, everyone's kind of square how you're going to put this stuff into a data center. And then finally, information flows I've just mentioned. The key thing being they're a proper model. The information flowing over the flows is represented in a domain model. And that one, it clearly shouldn't know an operation. I should have suppressed that while putting it on the diagram. I've reused something from another part of the presentation. A few things to avoid. This is, some people would agree with me and some will hate me for it. I would strongly suggest avoiding, excuse me, I'm just getting some water, use case diagrams. The reason being, most people draw a use case diagram and then present it to me and announce that they've got a use case model. And actually, they've got nothing in here inside the use cases at all. There's an excellent book Craig Coburn wrote years ago called Effective Use Cases, I think. It actually defines what's inside, and that's what all the value is. There's no harm drawing the picture, except that I find that that's all people do. And the picture's pretty content-free. All that information will be in the textual descriptions. And other than giving a bit of an overview to maybe make people feel better that someone's thought about stuff, this diagram really doesn't add a lot. The other thing is complicated state models. That's a real one I got from the internet. I nearly understand it. It's Java thread states, which we're all very familiar with, which of course are very simple. Some people have got complicated state models. That's a pretty complicated state model to deal with in a real system. Simple state charts are really useful, where you've got a business object that goes through states and you've got actions to take it between states. Brilliant. 6 states, 8 transitions, all makes sense. If you end up with a monster like this, just be very careful that you understand it and that it's useful to anyone else. And in particular, the semantics get quite complicated. What does it mean to leave that state? For example, down that transition. You really have to kind of stop and think. And as soon as you have to stop and think a lot about it, you've definitely got something you need to be aware of. And then collaboration diagrams, I've always kind of, I mentioned this earlier, I can kind of move on. People don't tend to understand what they really mean. And actually, I've just not found them to be terribly useful. The final thing is reverse engineering the code into the tool and then announcing to me that I've got a system model. That's the best way to wind me up on a Monday morning. So show me one of these and go, yeah, I'm all done, I've got a model. No, you haven't really, have you? You've got the code rammed into the UML2 meta model, and it's actually much, much harder to use in this than in a decent IDE. Why did you bother? It just adds absolutely no value. The other thing is having possibly quite a decent model, but presenting it to people who cannot understand it or don't care. I know I keep saying this, except that people keep doing it and using the same picture. And I think it's because they're drawing pictures. If you've got a big picture you've put a lot of effort into, it's very hard not to use it again and again because it's very expensive to create another smaller one for someone else. If you've got a model, you can create many pictures really very cheaply. And then a few pitfalls. Just remember, model with a purpose. Make sure somebody cares. Don't spend a huge amount of time on modelling unless it's actually giving you value. I would argue most of these models you can do in an hour or 2 each, and they are obviously useful to someone in most projects. Where modelling went wrong was teams. It's a bit like where enterprise architecture goes wrong. Teams of people paid to model. So what did they do? They modelled, and boy did we get a lot of models out of them. I'm not sure we got any business value, but we got a lot of models because that's what we asked them to do, to be fair. So it's making sure that something takes a reasonable amount of time and will pay back. And finally, trying to represent the code in the UML. That doesn't work at all. Finally, on tools, why bother with a tool? Well, actually, you don't need to. There's absolutely no reason you need to use a tool to get value out of UML. You can use a drawing tool or you can use a whiteboard. That said, tools, in my view, help you keep consistency because there's a model underpinning it. They help you to extend the language. Using profiles kind of on a whiteboard, it's all just a bit high ceremony to do on a whiteboard. You can do it, but it's just a bit fiddly. The other thing is keeping your model safe. I've kind of noticed this a couple of times that people put models on the whiteboard because I'm in a very agile environment, which is great. It all works very well. But one of the side effects of the modelling side of it is, even if they're not using UML, they've drawn something quite sophisticated on a whiteboard, and they stand back and they take a photograph on their iPhone, all good so far, and they email it to themselves, and that's all fine, and it goes on the wiki, and that's all fine, and then no one looks at it for quite a while, weeks. And then the whiteboard gets cleaned. Obviously, it would. Somebody else wants to use it. And then someone goes to the picture, pulls it out of the wiki and prints it and goes, I can't make this bit out at all. Let's talk to Tom. He obviously did that bit. Tom, what was this bit? And I don't remember. Something to do with trading, I think. If you've just taken a picture, for goodness sake, make sure the information is intelligible and secure, and you keep it somewhere sensible. The tools kind of help you to do that because they tend to have server components that keep stuff and version it and allow multi-user access and all that good stuff. Especially if you've got a repository, they just encourage reuse. If you've got a lot of stuff in the model already, creating new bits of it is very easy. It's like if you hand somebody a blank piece of paper, getting started is hard. If you hand them something to work from, they tend to get started far quicker. Similarly, sharing, just people can collaborate. And reporting, as I mentioned, most of the tools have got something like Jasper built into them, and you can generate a whole lot of stuff at the back in many different formats with relatively low effort. I would say if your tool doesn't do most of that, I would question whether you should be spending money on it. That's my challenge to many of the tool vendors, because a lot of the tools don't really enable those things. There are many popular tools. They kind of fall into the diagram editors, the Visios, which are absolutely brilliant at drawing diagrams. And if that's what you need, go ahead and use one. But just be clear that's what you need. The simple tools of varying sorts, and there are too many to even talk about, and I don't have experience of more than about half a dozen, and there are dozens of them. They all have different strengths and weaknesses, and most of them, frankly, I think if you put much effort into them, you won't get much return on investment. And then you get the fully featured UML tools. Magic Draw, Enterprise Architect, and RSM are 3 poster children for that. I will say I have absolutely no links with the Magic Draw company. In fact, I pay for my own personal licenses of Magic Draw. They won't, despite the fact I talk about them, they won't give me any free licenses. I use Magic Draw, and I think its usability is a bit mixed, but I think it's very powerful and works very well. That's my personal view. I know other, especially independent architects, partly because of the price point, who swear by Enterprise Architect and say that it's absolutely excellent. I used it some years ago and it was pretty sound then. And there's RSM, which a lot of people end up with in their firms. RSM 6 was a horror show with many, many things wrong with it, particularly profile support. I've not used RSM 7, I'll be honest, in anger, but I'm told by people who do use it, it's a step change, and they realised what the competition was. And a bit like just too late with WebSphere, they realised what the product should be like to use. Just too late with RSM, they've realised it should have been a lot easier to use to start with. And apparently RSM is now pretty easy to use as well. So decide if you want to draw diagrams. Decide if you just want to do sketches, and decide if you want full UML support. Be clear why you're buying the tool. Or indeed, if you're adopting an open source one, it's not free. It will take time and effort to learn, integrate, and use. Be clear what the ROI is. So in summary, UML is the classical curate's egg. In my view, it's very good in parts. And there's parts of it you need to avoid. I find it to be very valuable for that set of diagrams, which form a model of the systems that I work on. But it's very, very important to tailor UML so that the pieces of your model actually mean something to the people who are going to use the model, be you or anyone else. If you're not specific by tailoring the meta model, you end up with just generic, rather woolly diagrams that nobody's quite sure what they mean. And to be fair to the creators of UML, that's not what they intended. The reason they built profiles in is this first-class, user-accessible part, because they recognized it was absolutely crucial to build your own DSL before you started creating models. It's just that somehow in the wave of tools and training that kind of came out, the point was lost. And profiles are often taught on the Friday afternoon at 4 o'clock, when actually everyone thinks they know UML by then, and actually they've missed the most important part of starting a UML process. And finally, don't start with the tools. It's all about the models, and make sure that those models are created with a definite purpose. The books that I've found useful in this area, clearly mine, do go out and buy another copy for Christmas. I'm sure there's someone in your family who doesn't have one. Jamalo's book is quite good, a little dated, a little bit. If you want to know all the diagrams, but you want to know them in a fairly pragmatic way, Arlo's book is very good. Fowler's book is the classic. It skips quite a lot of it, and I think by the 3rd edition, frankly, it's getting a little bit tired because I'm not sure he was doing a lot to it, and I think it's maybe degraded a little bit, but it's still got a lot of useful introductory information. Coburn's book on use cases doesn't use the UML use case diagram once, and therefore is the most useful book on use cases out there. And finally, the spec is actually quite accessible if you're prepared to put a little bit of effort into understanding it. It doesn't take a tremendous amount of effort. So it's a lot less effort than learning C#. But it does require a little bit of effort to get into. But there's a lot of stuff there that you'll see in the tools that this book in particular doesn't go near, which you might want to know how to use. And that's how to go. And it's freely available from the OMG. So we're out of time, and I think it's time for lunch. So thank you very much for coming. I can take questions afterwards, and we should probably go and get some food. Thank you.